Uh, Hello. Okay, so we are live and I will solve graph problems today again. So last time we solved cycle finding. Okay, and we will start from flight routes. Okay, we will start from flight routes. So the question is that we have to find k shortest flight routes from Sirjala to Metsala. A route can visit the same city several times. Okay. There can be several routes with the same price, and each of them should be considered. Okay. Hmm. These are one directional flights. That means directed graph, and we have to find the k shortest uh, route. Okay, so basically we need to store k uh, shortest distances from 1 to n. So that means we cannot do it n into m. So Bellman food is out of the scope. K is less than equal to 10. Okay. K is less than equal to 10. Okay, so we have a directed graph we have a directed graph. Okay, for example, if we take this one, okay, so we have a graph. One is connected to 2, okay, one is connected to 3, 2 is connected to 3, 2 is connected to 4, 3 is connected to 2, 3 is connected to 4. Okay, and this one is weight as 1, 2, 4 is weight 6, 1, 3 is weight 3, 3, 2 is weight 8, 2, 3 is weight 2, 3, 4 is weight 1. So if we so we have to find the k shortest routes from 1 to 4. So before that, so basically number of ways we can reach so number of ways we can reach 4 depends on its neighbors, right? Basically it's where we reach from which nodes we reach to 4. What are the number of ways to reach them? Okay, so we depend on that. So number of ways to reach 2, number of ways to reach 4 will depend on how many ways we can reach 2 and how many ways we can reach 3. So reaching 3 we have 2 ways, basically from 2 and from 1, and reaching 2 we have 2 ways, from 1 or 3. Okay, so and we can go multiple times, right? So we have to find the shortest in all of these. So what if we tried to do what if we try to maintain a set of n set, basically? Okay, it will contain the k smallest distances to reach from 1. Okay, for 1 of course it will be 0. For 2 we have 1 here. Okay, and for 3 it will be 3 initially, and for 4 it will be 7, and we have 4, and we have another way. For 3 we also have 3, and we have 4 here also. How am I doing this? Basically I'm relaxing the edges. Whenever I'm relaxing the edges and updating the distance to v, I'm storing, not updating it directly, I'm storing it in the set. Okay, because anytime there is a change, that means that we have a new candidate for the shortest distance, right? Or for that matter, a distance. So when we relax 1 to h, it will be 1, we will store 1 here. When we relax this h, we will store 3 here. When we relax this h, we will store 7 initially, and relaxing this edge we will store 4. Okay, now when we relax this edge for 3, it will be 3 again. Okay, oh, so actually is my stream affected? Kind of. I'm not sure how long my laptop will hold. So basically there is a power outage, and let's see if we can solve this problem. So you see what where I'm going with this. Basically we are relaxing each edge and then storing the possible shortest distance in a set, and that set will allow us for that k, or that set will store the k shortest distance for, you know, but there is a thing, right? If we store it in a set, then okay, instead of storing all the answers in set, I think we should store only answer for 4th, or basically the nth one. Okay, what will happen if I don't do it? So if I don't process the edges properly, there is a risk of me not so I think there is a risk of wrong answer, I think. So for example, shortest distance of 2 can be 1, or we have 11, and also we have 1, 2 and 11. Okay, so we have 1, 11 and 11, 3 answers, right? And if we process 4, we have 7, 4 and 4 and 12. Okay, and again 12. So, and we also have yeah, we have 12, 17 also. So we need to okay, what if I try to do a Dijkstra? So if I do Dijkstra, then mm, we can store same node with different distance. Okay, so think we in some cases we risk running out of memory and time if you do it that way. So if we try with Dijkstra, okay. Okay, then what we will do is when we find the current, okay, we'll just do this. Hmm. How do we maintain the? How do we restrain the number of states produced during this loop? So so if we do the condition check, where if we already have a better answer for it, then we skipped it, right? And if we do that, then there is that defeats the purpose of the solution, I think. So we need to be able to somehow retain a few of those, and I think ignore the rest. But how? This is a one directional, na, so I don't think there will be. So I don't think we will have a back edge, so it should be fine. Not. So if there is a cycle, then we have an issue. But yes, for a cycle there is an issue. So we need to. So for example, here 2 and 3 are in a cycle, right? So reaching 3, we will have multiple ways of reaching 3, and that will cause memory issues. So okay, I'm going to do one thing. VLL count n plus 1 initialized with key. When I process the current one, I will check if count of the current is greater than 0, then only, okay, if it is less than equal to 0, then we will not do anything, we will just continue. Otherwise, count of the current will be decreased. Okay. And here inside the loop, inside the neighbor loop, we will check. No, we will check what? We will just store. Okay, we are going to store it in the queue, right? So we will do it like how are we going to do this? If current is double equal to n, okay, then answer dot insert d. So one way path, na. So We'll see. Answer dot insert D. Here I will insert pq dot insert the distance plus the current node. Okay. This should work, I think. And we need to okay, how about this? Okay, so DFS. What DFS? Where am I using the DFS? We don't need this one now, so we'll comment it out. K was not declared. Four, 7 and 14. 14 how? 14 how? Okay, this is a set, no? We don't want set. We want multi-set. Or I think we should go with map. And we'll do this, and here what I will do is So we'll start from 0 and we will run and we will print answer current. Answer D++. Four 7 14 0 0 0 0 0. Why 0? Is it because of the loop? Think so, yes. $14 again. Where is this 14 coming from? Oh. So we have 8 and 6 14. But 1 2 3. Let's see. So I have a priority queue. Okay. This priority queue is what? It's shortest thing. No, this is the other priority queue. And this is a min heap, this is a max heap. Okay, so we are storing k nodes, k states for each node. Okay, so we'll do it like this only. Okay, so that is a min heap that we are using, and inside we are using a max heap. Okay, so we are using a max heap here. Oh no, so we are using a wait a second, higher value, higher priority. So we are using max heap here. Okay, and then we are using a min heap here. Okay, this is done. We don't need this. Okay, we are not using set, so we don't need this. We will do it like this: pq dot top and pq dot pop. Current is this, this is this, and inside we will do simple check. If the distance for current dot top, which is the maximum value, if this d is greater than this, then we don't want to include this, we'll discard it. And for the rest we will check two things. One is if basically we will calculate the temporary distance, which is d plus node dot ss, and we'll check if distance to this node dot. Okay, before that we'll do this neighbor is node dot ff, and w is node dot ss. So w, and if distance to this ng dot size is less than k, then what we will do is we will push this new distance, which is the temp. Okay, and we will also push this new distance here. Otherwise what we will do is we will check if the distance that we have now calculated is less than the distance, the maximum distance of the max heap in for that particular node. And if that is the case, we will do dist ng dot pop, then dist ng dot push this temp and ng, no, not ng, just this temp, and the same we'll do here. And after all this, I think we should be able to, while k minus minus and dist n dot empty, we will do cout dist n dot top, or not cout, we will have an answer, and we will push back all the elements in the answer and then reverse it, because it will be in reverse order, no? So we need to do it this, and we'll do this, and after that we will print all the answers. Let's see. 744. We need to reverse the answer, and we're done. Let's try to submit this. It should work because it's the same solution, so it should work. Okay, runtime error. Hmm. Okay, the code is exactly the same, so I'm not sure why I'm getting a runtime error here. And my laptop will not. Okay, again. My laptop's battery is almost at 33%, so it is not going to last long. Okay, it's because of the size, right? Oh, it's because of the size. Uh, what is the size here? Read and that was because of size only. Okay, the next question. Byteland has n cities and m flight connections. Byteland has n cities, and so this was done using Dijkstra. Task is to design a round trip that begins in a city, goes through one or more other cities, and finally return to the starting city. Every intermediate city on the route has to be distinct. Cycle? One way in connection. So I think we've already solved a round trip question. Let's try to submit that to the solution and see if it accepts. Okay. Round trip 2. Here is this. What is the output? 1 2 3 1. Okay, the only thing is this is a one-way trip. So this. Okay. This is a one-way trip now. This is an issue. Before there was not a restriction on the cycle direction, but now there is. Okay, so 1 3 2 1 2 4. Let me draw this graph. This is round trip 2. Okay, so the graph we have is 1 3 2 1. So 1 3, we have 2 1 2 4 and 3 2. 2 4 and 3 2 and 3 4. So so we start from 1. Okay, we will start from 1, then 3 2 1 1 3 2 1 1 3 2 1. So the code right now, if when we start from 1, it will mark 1 is true. Okay, we'll go to 3. 3's parent will be 1, so we will have a parent 1 here. So this is 1 2 3 and 4. 1's parent is no one right now, it is -1. So we'll go to 3 from 1, its parent will be 1. 3 can go to 2 and 4, so its parent is 3 now. And from 2 we can go to 1. Okay, the moment we go to 1, 4 we cannot go anywhere. The moment we go to 1 from 2, we will see that node has already been visited. Okay, we see that node has already been visited. It is not a parent and it has already been visited. That means it is a cycle. When parent node is equal to src, parent of node is equal to src, so we will set it to 2. Okay, and the starting point will be 1. And so we will start like this: 1, and then 2 3 and 1. So in the code what we are doing is we will push 1 and then parent of sp, so 2, temp is not equal to sp. Okay, so temp will not equal to 1, temp is equal to parent of temp, so 2 and 3, and we pushed it. Okay, okay, so we just need to reverse it now. Cy and done. Done. Let's try and submit this. Okay, runtime error, wrong answer. Why 1 to 1 is impossible? Hmm. I'm not sure why 1 2 is not acceptable. 1 2 2 1. 1 2 2 1. So there's this cycle. Should be distinct. Huh? It is a round trip. Holy shit, what is this? So what we are doing in this code is we are uh, starting DFS from an unvisited node. Okay, so for example we'll start from 1 and here we will set its visited state to, we have 3 different states. Okay, so 1 is of course 0, so initially all of them are 0. This one is also, but when we visit it we will set it to 1, and then we will go to its neighbor which is 3, And when we do, what we will do is we are keeping track of array which will contain a cycle. So basically we have initially 1 and then we added 3 as well when we are traversing the neighbors, and then from 3 we will start another DFS. Okay, this DFS will either go toward 2 or 4. So if it goes toward 4, then we see that 4 cannot go anywhere, so DFS of it will not return true, it will return false. So we will track back, basically backtrack. We will backtrack, and it was when forward as added and 4 will be popped off when we backtrack. So again we have 1 3, and then we go toward 2, and from 2 we again can go to 1. Okay, only 1. So we go to 1 and see that 1 has already been visited, right? 1 has already been visited, and we see that 1 has already been visited. So we will return true from here, and our DFS will be stopped there. Our DFS will stop there. Our DFS will stop there. So now we have this cycle. Okay, and I'm not sure what this is doing. Okay, so there is a possibility that the cycle is not ending with this. Okay, so hear me. What if we our cycle was something like this? From 2, from 4 we can go to 2. So we started from 1, but as we went to 3, okay, we can go 2 ways, right? 2 or 4. So when we went to 4, we see that we can go to 2 again and then 3, right? So the cycle will store this in the cycle. Okay, yeah. So what we are doing is basically we are containing the elements in cycle only by reversing it first and then popping from behind until we have this and this matching, and then we will reverse it again. So that is what it is doing. Okay, fair enough. What? Okay. Course schedule. N courses, M requirements, course A, is a topological sort, toposort. Shall we do it? Or shall we leave it for tomorrow? I think we'll leave it for tomorrow. And with that, I think it is time to end the stream, and we will continue tomorrow with this with the rest of the graph problems. And yeah, we'll meet tomorrow then. Till then, take care and peace out.